Hello, in this video we will talk about the nth root of a complex number. So first of all we will define it. We suppose that we have two complex numbers and there is a natural number from this set, which is called the set of natural numbers. We say that W is the nth root of Z if and only if W to the power n is equal to Z. If W to the power n is equal to Z, then we say that W is the nth root of Z. Okay? So let's do an example. In this example, we will explain if you have a complex number, then how you can find its nth root. So here you have an example. You have to find the fifth root of negative 32. So in order to find the fifth root of this number, we have to apply the definition. Since nth root of W is equal to W to the n equals Z. So nth root of Z was W to the power n. Here, fifth root of this is W to the power 5. So, let W to the power 5 is equal to this number, which is negative 32 by definition, because nth root of Z is equal to some complex number to the power n is equal to this thing. Similarly, here you have fifth root of this corresponds to Z and this corresponds to n, and W is missing. We have written W, we don't know W, but we have to find W here. So we can find because it is what we had to determine. You can write this complex number in the polar form. You know every complex number W can be written as polar form, since W can be written as in the polar form named as R times cosine of theta plus I sine theta, right? But we need W to the fifth. Here we have W. How can we find W to the fifth? W to the fifth must be equal to, you know how to find the fifth power of this number? You have to find the power of R, fifth power of R, and here cosine of 5 theta plus I sine of 5 theta. This is how we find the fifth power of a complex number, because I have explained this thing in the previous video. Okay, so this is your W to the fifth. Now you can plug this value of W to the fifth here, then this thing will become, since W to the fifth is equal to negative 32, and here W to the fifth is equal to this thing. So I can write this value of W to the fifth here, and this is equal to negative 32. You can also find the polar form of this complex number. Since I have explained in the previous video, if you are given a complex number, you can easily find its polar form. So without going to the details, if you want to see how we convert this number into polar form, you can see my previous video. So I am just directly writing the polar form of negative 32, which is equal to 32 times cosine of 180 degrees plus I sine of 180 degrees, right? So this complex numbers polar form is this one. Okay, if you don't know, you can see my previous video how this comes from this. And this thing is as it is, which is r to the negative 5 cosine of 5 theta plus I sine of 5 theta. If you compare both of the values, you will get r to the 5th is equal to 32. So if r to the 5th is 32, then r to the 5th is equal to 2 to the power 5th, because 2 to the power 5 is equal to 32. And if you cancel the powers on both sides, you will get r is equal to 2. So we have determined the value of r, but now we need to find the value of theta also. If you compare these values with this one, you will check 5 theta will be equal to 180 degrees. Also, we can write 5 theta equals 180 degrees. So if you divide on both sides by 5, before dividing by 5 on both sides, you can write 5 theta equals 180 plus k times 360 degrees. Why I have added this thing? If you see from this equation, you can realize that 5 theta equals 180 degrees. But I have told you in a couple of videos ago, if you measure angle, for example, this is the angle, you want to measure this angle. If you measure this angle is theta. But if you measure the angle from here to here, here, and go very long and then come back, that means this is theta plus 360 degrees. So previously theta and theta plus 360 degrees both are coming at the same point. Both are determining this angle, which is the same, right? So this means if you add 360 degrees or you subtract 360 degrees or any multiple of 360 degrees, any multiple means this is 1 times I added 360, you can add 2 times, 3 times. Similarly, you can subtract 2 times, 3 times. Therefore, from this equation, we can see that 5 theta equals 180 degrees, but this angle can have more twist, because this theta can be theta or theta plus 360. We don't know which angle is here. So in order to cover all of the possibilities, we have written 5 theta equals 180 plus k times 360 degrees. So any multiple of 360 degree will make no difference. Okay. Now you can find theta by dividing 5 on both sides. You can get theta equals 180 divided by 5 plus 360 degrees times k divided by 5. If you divide this by calculator, you will get 36 degrees plus this thing will be 72 degrees. 72 times k. This is your theta. But we need to find fifth root, right? Because we had to find fifth root of this number. So in angle, you have k, and k is any integer. This integer means this set is equal to 0, 1, 2, 3, up to so on. Minus 1, minus 2, minus 3, up to so on. Okay, that means this k is one of these numbers. Actually, we have to find fifth root. That means we will put 5 different values from here. Okay, normally we write this set in this way. Here we'll write 0 and 1 and 2, 3 up to so on. And here we write -1, -2 up to so on. What we will do, normally we have to take 5 different values of k. So I will take these 5 different values, 0, 1, 2, -1, -2. Okay, so first of all, I will put this value of k, which is -2. If I put -2 here in theta, then I'll get theta 1 equals 36 plus 72 times -2. What's that? If I plug -2 here, okay, if you check that this angle becomes negative, so try to make it positive. So since if you plug here -2, this angle will become negative. So shift your everything here, 0, 1, 2, 3, 4, up to so on. So try these 5 numbers, right? So that your angle becomes positive. So your first value of k is 0. By the way, you can take any 5 values. It's up to you, totally up to you, but it's good if you make angle positive, right? So for k is equal to 0, here you will write 0. So theta 1 will be 36 degrees plus 0. And for k is equal to, the next value is 1. I'll plug k is equal to 1. Then theta 2 equals, this is the first theta, this is second theta. Theta 2 will be 36 degrees plus 72 times 1, which is what? 108. 36 plus 72. This, and for k is equal to 2, what will happen? Theta 3 will be 36 plus 72 times 2. If you calculate these values, you will get 180 degrees. So now for k is equal to 3, because you have to check these values, these 5 values, you have to plug 5 values. Theta 4 is equal to 36 plus 72 times 3, which is, if you calculate from the calculator, you will get 252. Now for k is equal to 4, theta 5 equals 36 plus 72 times 5. If you calculate it from the calculator, you will get 324. These are 5 different angles. Okay. So you have 5 different fifth roots. So the first root, which is W0, W0 corresponds to k is equal to 0, will be r times cosine of theta. I think you should write W1. I think I should change the notation. For k0, I should write here theta 0. For k1, I should write here theta 1. For k2, I should write theta 2. And for k3, I should write theta 3. And for k4, I should write theta 4 on the index, right? So for w1, I should write for W0, because I will start from 0 here. So W0 will be equal to R cosine theta 0 plus I sine theta 0. Since we found the value of R, which is 2, so I'll plug here 2, and cosine of what is theta 0? Theta 0 was 36 degrees, so right here cosine of 36 degrees plus I sine of 36 degrees. Then W1 is R cosine of theta 1 plus I sine of theta 1. Since R is equal to 2, cosine of theta 1 is 108 from here. So I will write 108 plus I sine of 108. And W2 R times cosine of theta 2 plus I sine of theta 2, which is equal to R is equal to 2, cosine of theta 2 is equal to 180 degrees. I'll write 180 degrees plus sine 180 degrees. W3 equals what? R cosine of theta 3 plus I sine of theta 3, 2 cosine of 252 Now the last one is W4, cosine of theta 4 plus I sine of theta 4, which is equal to 2 times cosine of what? 324. So this is how we find the fifth root of a complex number. You can find sixth root and any root of a complex number in this way. So using this example, the general formula is if you are given z, which is r times, okay, r0 is given, cosine of theta 0 plus I sine theta 0. If this value is given, then nth root of z is obtained by using this formula, which is equal to r to the nth root times cosine of theta 0 divided by n plus k over n times 360 degrees plus I sine of theta 0 by n plus k by n times 360 degrees. This is the general formula. In this general formula, you will plug different values of k from the set of integers. From this set, from here, you will plug different values of k so that the angle does not become negative. You would keep on plugging the values of k from 0 to n, then you will be able to find the nth root of any number, any complex number. Here you have some examples. Find the fourth root of 1. This is first example. The second one is find seventh roots of 128. Negative 128. Try to do these examples just like I did in this video and then show me if you have done. Thank you.